The first part of this course we use mostly four of these tools, and they are the hardware simulator, CPU emulator, assembler, and text comparer. So I'll be explaining each of these tools one by one. So here, before we dive into that, here I have an HDL code of a full adder. This is how the hardware description language code of a full adder looks like. So the first section here you see is the external pin, or the external pins, the input pins and the output pins. And here you can see the different internal chips of the full adder, the chips that we use to build the full adder. So here here you can see there are the input pins A, B and C. A and B and C are 1-bit inputs, and the C basically, the input C basically is the carry from a previous adder logic. In the second line you can see out some carry. So this is the output of our full adder. This is the output of our full adder. This is the input. And in the second part you can see that I have used 3 chips. I used 3 chips to build the full adder. That is 2 half adders and 1 OR. So the basic logic of this is you first add A and B together to get the sum and the carry, and these are the intermediate outputs. And this, in the second half adder, we add the sum of the first half adder and the input C, and we get a sum and the carry, and the sum of the second half adder is our output of the full adder. This output of the full adder is coming from the half adder, and then we have a carry also. So to get the carry of the whole operation, we simply OR the first carry and the second carry. First carry here and the second carry here, and we get our output carry of the full adder. This corresponds to this output. So this is how we describe an HDL code of a chip. Now we will see the code in action in our hardware simulator. So we'll start our hardware simulator. You can see a window has appeared. So to load the HDL program, you simply click this button in the corner of the window, top left corner of the window, and to load your HDL program. Load in our full adder, and you can see the program is loaded in the bottom left corner of the window. And in case there is an error, it will be showed in the bottom of the window, and the program will not be fully loaded into this little screen that you see here. So here you can see a number of boxes, which is input pins, output pins, internal pins. So here you can see the input pins, the input pin name and its corresponding value, and here the output pins. These are the output pins, the sum and carry. These are the output pins. Internal pins are basically the pins that belongs to the internal chips of the full adder, half adder, namely these 3. So to test our HDL code, we can manually type in values, and you simply press the arrow button at the top of the screen, and you can get the output. You can see the respective values of different pins in all these little boxes. You can see the input, you can see the output here. You can see the internal output, the values of the internal pins, and as you get the output values here, you can compare it with a truth table of the full adder. So you can do that, or you can use a test script. The nand2tetris suite provides test scripts for each of the programs, so we can load one of them in the test script, and we can run the whole code so that many cases are tested. So for that, we click this button at the top of the screen, top of the window, which is called the load script, and you load the respective test script. You can see the test script on the right side of the window. Now we can simply press the play or the arrow button, and you can see it executes the test script step by step. And you can see the different values that are changing. You can either do that, or you can press this button that says run, with the double arrow, and it will just run the script till the end. And if the test is a success, you will get a success message at the end of the window, or else you will get an error message in red. You can either slow down or speed up the execution process of the script here. And if you want to restart the script, you simply press the reset button on the top, the double arrow pointed to the left. So this is the basic function of the hardware simulator. And next we will check out we will run the CPU code, the CPU HDL code in our hardware simulator. So we load in the CPU chip, and you can see the various input pins and the output pins here, and you can see the internal pins, different internal pins, and you can also see the current states, and you can also see the different registers, A, D, P, C, and you can also see the different values of the ALU, different values of the pins in the ALU. So you can either type in your own value and test it, or you just load a test script for the CPU, and then you click run, so that the whole script is run till the end. You can see all the values changing as it runs each step, and then if the CPU code is correct, we will get a success message in the end. So that is how we check the CPU code in the hardware simulator. So the next tool we are going to discuss about is the assembler. So this is the assembler. So assembler, as we all know, is a program that converts assembly program to the corresponding machine language code, which is simply a series of zeros and ones. So what we do is we load in the hack assembly file, then you press the arrow key at the top. So when you click this button, it is executed step by step, and you can see that the commands are skipped. The white spaces are skipped as well, and when we reach the assembly codes, it starts translation and it goes on. Or you can either fast forward it by clicking the double arrow button there, and it goes on until the end. You can see each assembly line is translated line by line into its corresponding machine language code. So it goes on until the end, and after the conversion is done, we can either save it to our destination as a hack file. The hack file is our machine language file, machine code file. So we save it, just click the button and we save it. So click this button, and just like before, it starts from the beginning. You can execute the code from the beginning. So there is another button here which directly translates the code without any delay, and then you can just click it, and then you can save it without translating it line by line. Now there is another feature where we can compare two hack files. So what we do is, it's called the load comparison file button. You click that, and you load in your hack file, which is your machine code, and then you convert the assembly code that you have loaded on the left side, and you convert it into its respective machine language by running the assembler. As you convert it, you can see that they have already done the comparison, and the result will be displayed in the bottom of the window. So this is a success. So the next tool that we are going to discuss is the CPU emulator. The CPU emulator is a program which emulates the hack computer, including its memory and CPU and everything. Here you can see this is the memory, this is the instruction memory, there's a ROM, and this is the data memory, and you can see PC, A, D, etc., which shows the current value of those registers, and also the same goes for the ALU. So we will load a simple program into the ROM. So this is actually stored as not as an assembly file but as a machine code file. This is just for the user's convenience. So basically this program adds two numbers 2 and 3 together and stores it in the location 0. So we should get a 5 here in the location 0. So we just go straight away and run the program. You see the different current values of the different registers and the ALU, and you can see the program has already ended, and the result is as expected in the 0th register of the RAM. And as you can see, there is no stop loop, infinite loop to stop, to keep it from going on and on. It will just, PC will keep increasing till the end of the ROM address. So what you do, you can just stop it, and there you have it. That is how you run the CPU emulator. So the next and the last tool that we are going to discuss is the text comparer. This is basically a command line tool which is used to compare two text files and see if they contain the same contents or not. So we'll create two text files. See how we created our two text files. Now we'll compare. The text comparer takes in two arguments. These arguments are text files. So I'm gonna type them down, and you can see the result on the bottom. It says comparison failure in line 1. So if there is any comparison failures, then it will show where it went wrong, and if the contents of these two files are the same, it will just print out a success message. And you can use this instead of using the big assembler program. You can just compare the two hack files using this text comparer instead of the hack program that was provided, and not go through such the hassle of opening it. And so this comes to the end of the tools we use in the first part of the nand2tetris course. So thank you.